this is Gary Freed of Z-Axis Corporation. The video that follows, the Advanced Aviation Systems Design, was produced by Z-Axis for the FAA in October of 1988. This 10-minute program was intended to prompt members of Congress to approve plans to modernize the infrastructure of the United States air traffic control systems to handle the increased flow of air traffic in the future. Z-Axis worked with the FAA to create the animation of the advanced systems. We also went to FAA headquarters in Washington, D.C. to record then Administrator Alan McCarter making the closing remarks for this video.
The growth of aviation transportation in the United States and around the world during the past 30 years has been phenomenal. Forecasts for the next 30 years project increased demands, which have become a matter of concern for aviation planners. By the year 2020, for example, the number of passenger miles flown annually is expected to quadruple. In the mid-1980s, the President's Office of Science and Technology Policy devised an action plan that recommended enhancement of the safety and capacity of the current aviation system. As a result, the Federal Aviation Administration established an Advanced Aviation System Design Team in January of 1987. The team was composed of representatives from the FAA, NASA, DoD, and DARPA. Relying on major support from industry, the team began a long series of briefings and meetings with aviation experts, both in the U.S. and abroad. A final system design concept was presented to FAA Administrator Alan McCarter in June of 1988. That design will be used as the foundation for a planning process which must begin now and continue into the 21st century. What can be seen ahead as we look toward the future? What does it mean to today's pilot and air traveler? What changes does the Advanced Aviation System Design envision for them and for the generations to follow? The fundamental purpose of the Advanced Aviation System is to provide the technical and operational framework needed to ensure the safe and efficient transport of people and goods in the next century. The system is based upon the concept of shared responsibility between people and technology. Its major physical components are satellites, ground facilities, airports, vehicles, airspace, avionics, and people. All aircraft operating in the new system will use satellites and a universal time reference to determine and communicate instantaneous positions. Satellite networks offering global coverage will enable accurate and reliable position determination to within 10 meters. Communication by satellites and data links will permit information throughout the system to be accessible at the right place and the right time. In order to establish a flexible structure which will meet worldwide aviation requirements, cooperation on an international scale is required. The focus of operations in the 21st century will be within the Aviation System Management ground facilities, situated around the globe. These facilities will be strategically located, depending upon technical, economic, meteorological, topographic, and international considerations. Functions as diverse as satellite control, airport traffic flow regulation, and weather dissemination will be conducted at these facilities. They will also serve as principal processing facilities for aviation information and will oversee the effective transport of people and goods within the system. As viewed globally, air transport will be greatly enhanced by the use of superports, new airports specifically designed to take advantage of the wide range of vehicles available in the next century. Each superport will be linked to regional facilities such as rotor ports, stall ports, heliports, seaports, as well as existing airports with new operating procedures. Only a few superports, perhaps from 6 to 9, will be needed around the world. They will represent the confluence of aviation, where both people and cargo can be rapidly transferred from one vehicle to another. A variety of subsonic, supersonic, and hypersonic aircraft will provide the opportunity to transport material and passengers from widespread distribution points. Future subsonic vehicles will have substantially increased performance capabilities. This category includes rotorcraft, providing efficient takeoff, climb, subsonic flight, and landing, as well as power lift vehicles, offering vertical or short takeoff and landing capabilities. These aircraft can relieve ground and air congestion around densely populated areas. Supersonic and hypersonic vehicles will cruise in the upper atmosphere at velocities that may exceed 20,000 miles per hour. Space launch craft will be capable of superport takeoff, acceleration into low orbit, and return to Earth. The future system will make use of one global airspace that extends from the surface to at least 100,000 feet. Implementation of this far-reaching concept will require international cooperation and agreement. Where required, vehicles will fly in dynamic corridors, which will be continuously adjusted to fit traffic and weather patterns. These pathways will be dynamically configured to both maximize fuel efficiency and keep weather interference to a minimum. In the future system, all vehicles, regardless of size or use, will be equipped with ADS, Automatic Dependent Surveillance, a position determination and communication device intended to complement and eventually replace ground-based surveillance systems. New equipage, such as ADS, will be used to interface crew and cockpit with airspace, other vehicles, and aviation system management facilities. Special screens and heads-up displays will present a selection of virtual images in the cockpit. Vital information such as airspace corridors and vehicle routes can be dynamically presented. Synthetic vision, based upon remote sensing, will provide enhanced visibility of surface features for the crew in any weather condition, day or night. People will play a vital role in fully utilizing the new technology. An appropriate balance must be developed between machines, with their vast capabilities of collecting, processing, and distributing information, and the unique ability of people to understand, manage, and act upon that information. In order to make this vision a reality, the support infrastructure, which provides supplies and services and facilitates the exploitation of technology, needs to be in place in the near future. Research in all areas must continue to be encouraged at the highest levels and vigorously pursued throughout the aviation community. In addition to hardware and software development, new techniques and procedures must be established that will facilitate effective system operations. And as new technology becomes available, training programs must be implemented. The professional development of people must begin soon to ensure fulfillment of their proper role in the new system. Additionally, environmental considerations such as handling of exotic fuels for hypersonic vehicles must be examined and incorporated into new airport design. Another example of the type of research and development support necessary for a new system is the design and implementation of a new common language. This language might utilize a combination of fewer than 24 symbols and sounds to convey the 100 or so basic flight messages across the globe. The Advanced Aviation System design is an integrated concept in which satellites and data links are used for worldwide position determination and communications. International aviation system management facilities process data and oversee activities including configuration of dynamic airspace. New airports provide rapid transfer of people and goods. And a variety of specialized aircraft equipped with advanced avionics offer safe and effective global transport.
The final element of the system is its enabling policy, legislation, and regulation. Government decision makers must establish policies, develop plans, and create a legislative and regulatory structure for the orderly transition from today's system to tomorrow's advanced aviation system. Also, we must take immediate action to ensure that such a visionary concept is in place to meet 21st century aviation demands. This, then, is the Advanced Aviation System Design. The technology is available, the design is visionary, it is conceptual, and it is achievable.